Welcome. Today I would like to talk about inverse document frequency, or IDF. This is a very important concept when which you try to process data in the text form or written in the human language. So oftentimes when you are involved in text mining or information retrieval or other data science applications, you normally need to represent documents using words or phrases or terms. And there is a question about how much weight or score you can assign to each term for that representation. So IDF, or inverse document frequency, is almost the first thing that will come to your mind. I think it's so classic that it's something that you almost cannot avoid. So today I would like to talk about this concept and just to cover the basics. And in fact, will be the first of three brief videos I would like to make regarding inverse document frequency. Because this particular concept actually came from the information retrieval research, I would like to give you some background of it very briefly. And then I would like to get into kind of the heuristic understanding of IDF. And then, so that will be our video for today. And then in the next couple of videos, I would like to talk about the kind of the from two different perspectives. One from the probabilistic point of view, in terms of probabilities, how can we view IDF? And then from also information-theoretic approach, how can you understand IDF in terms of the amount of information that each word may carry. So this is kind of a broadcast of three videos here. But today let's start with the basic overview of information retrieval and where is this notion of inverse document frequency, how does it, what kind of role does it play? So let's get to it. So what is information retrieval basically? I think this is something that everyone is dealing with every day. Just think about Google, right? Information retrieval is about search engine. How can you find information, or how we can develop systems to help people find information. And so imagine when you go to Google and have this question in mind and type in a couple of keywords, right? Trying to locate the information or the web page containing the information that you are looking for. So imagine this query, expression of the Maid of Orleans. So, perhaps you know what this is about, but there are four keywords here, right? The Maid of Orleans, four terms. And so the question for information retrieval for search engines just as Google or Bing is to take these keywords and try to find, documents that match these keywords, right? And then once the matching documents are found, the search engine will then rank or sort this document in a certain order so that hopefully the most relevant or most interesting, most useful, piece of document will be presented to you first as a user, so that you find your information, you can go there, right? So, but first of all, what questions, what documents or what pages should be retrieved given this set of query terms, and which ones should be ranked earlier or kind of at the top, right? And this is actually associated with how much weight you should give to these terms, these four terms. Because think about this, you may find documents that contain lots of occurrences of the word the or of, right? But does those words, does having those words in the documents help you, with the question or information that you are looking for? Probably not, right? So I think if you understand that there is this question about how much score you should give to each word, then you may be able to find and be able to focus on which terms that matter most in the documents that you find, and then be able to rank them accordingly. So term weighting, or how much score or weight you assign to each term, is very important when you try to do this information retrieval and ranking. So let's look at these words individually as an example. So when we look at these four words, the, as you can tell in English, this is a stop word. It's very common. It's almost like too common to be useful, right? The word the appears in almost everywhere, every single document, also every single web page. And so it's too common or too frequent to be useful. On the other hand, of is similar, right? Of is kind of almost as meaningless as the, but it does provide some relational connotation. So maybe it's a bit more meaningful than the, but still it can also be treated as a stop word, too common to be informative. Now, if you look at the word made, right? The made is less frequent, less common, right? And so it suddenly gives you more information. But of course, maid can be ambiguous, right? It can be just a lady who is helping people with the household, right? But throughout the history, maid can mean also different things as well. So there's ambiguity, but there is still some information in the notion of maid. And then if you attach Orleans to maid, I think it gives more context. It makes the maid more specific, right? So Orleans is a specific and more meaningful word because it's not as common. It's not everywhere because it refers to a location, right? To a city. And so it gives the context. So as you can see, hopefully from this example, from the four words here, that the very common words are too broad or too common to be useful. And then the less common words or rare terms are more specific and more meaningful. And so you see this kind of frequency or how common a word is versus how informative a word can be. And there is this inverse, right? Inverse relation between the frequency and the meaningfulness. So here comes the IDF, or inverse document frequency. Based on our discussion, I hope it's obvious that the more common a word is, the less meaningful the word should be, right? And so if you want to give some certain weight or score to a word, you should give it less weight for the common words. For rare terms or words, on the other hand, they are more specific and they are more meaningful, such as maid and Orleans, right? So they should be given more weight. But how do we measure like how common a word is or versus how rare a term is? So we can measure this in terms of the number of documents or web pages a term or word appears in, right? So for example, on the web, if we simply count the number of pages containing a term or word T, that is the notion of document frequency. Okay, so number of documents or pages containing that particular term, that is the term document frequency of that term. Okay, and so if we are going to kind of derive or propose a term weighting mechanism, hopefully the weighting should reflect this inverse relation to the document frequency. So the higher the document frequency, the more documents that contain a term T, the lower the term T, the weight of the term T. So given this inverse relation between document frequency, which we use NT, right, to denote the number of documents containing that term T, and expected weight, which we can use, WT as a notation, right? So in this case, there's an inverse relation between WT and NT, okay? So when we think of this inverse relation, so WT should be a function, should be the inverse, right, of NT. So the first proposal, naturally, is simply to take 1 over NT, or 1 divided by NT as a weight, right? So this actually captures the inverse relation. So NT, again, is the document frequency, or how common the term T is, and then we just inverse it, right, to get the weight. This may work. There's just one problem here, however. So we're looking at the first proposal, okay? The first proposal is just to take the inverse. The problem here is that, think about if you are doing information retrieval or text mining on the web, right? NT can be very large, right? Think about how many documents containing the term the. It's almost every document on the web, so that can be trillions of documents. 1 divided by a trillion, it's a very small number. Even, less common words such as made can appear in, millions and millions of documents. And so 1 divided by millions is a very small number, and today's computers have a hard time to process, very small numbers. And so this becomes a problem. So we do not want to just simply use 1 divided by NT, right? So the second proposal is that, okay, instead of using 1 in the numerator, let's use a different number so we can make this number bigger, right? We can just multiply the number by a common factor, and to make the number bigger in general, so that can solve the problem of having 2 small values. And so the second proposal here is, let's multiply everything by capital N, which is the total number of documents in your collection. So on the web, the total number of documents or web pages can be a very large number, such as a trillion, right? So, and the small nt is not going to be greater, right? It's always equal or less than the capital N, right? So in this case, N, capital N divided by NT, or the total number of documents divided by the documents containing that term T, is always going to be greater than 1. So this is a number that can be easily computed, right? It's not going to be too small. So this solved the problem of the first proposal. So things look better, but there's still one more issue here, which is, think about this. Going back to our example of the maid of Orleans, right? So the is going to appear in every single document or page. And so N, capital N divided by NT. So NT in this case for the word the is going to be exactly the same as N, okay? And so N divided by NT for the for word the is going to be 1, right? So I hope this makes sense. But if you think about the words such as, a specific word such as Orleans, okay, NT can be a million, right? Even though million looks like a big number compared to the total number of documents, capital N, which can be a trillion on the web, a trillion divided by a million okay, that is going to still be a billion. So think about this. The weight in this case, in the second proposal, the weight for the word the will be 1. The weight for the words such as Orleans can be a billion. So there's a huge difference between the weight of the words. Maybe people can still argue this is good. But I think the problem is that once you have a much rare term, the weight will be so big or so great that it will render other weights or other terms' weights useless, because there is such big gap between them. So one rare term is going to dominate the entire equation. Okay, so with this, we hope to find some middle ground. Perhaps we can kind of dampen the difference, or the distance or the difference between the weights of the different terms. Okay, so in the third proposal, we can use functions such as the logarithm, right, to dampen the difference. So for those of you who know what a logarithm is, a log function is simply to reduce a number to its power or to its exponent. So here I use the example of log base 10. So it's reduced a number to the number of zeros that it has. So for example, base 10 log 1 is going to 0 because 1 has no 0 in it. And then log 10 is going to be 1 because there's 1 0, right, in the number 10. And then log 100 is going to be 2, right? So because 100 is 10 to the second order. So so this logarithm log function will still keep larger numbers larger, right? So the log of 100 will still be greater than the log of 10, which is greater than the log of 1, right? So if we are talking about ranking, it will preserve the same order. But however, the difference between these numbers will be reduced, right? So the difference between 1, 10, and 100 will be reduced to the difference between 0, 1, and 2, right? So this kind of serves the purpose of kind of dampening the difference of those weights. And so the third proposal is actually the functional form of IDF, or inverse document frequency. So this third proposal, WT, equals to log capital N divided by NT, right? Where capital N is the total number of documents and NT is the number of documents containing the term T. Okay, so this captures the inverse relation between document frequency, or how common a term is, and the expected weight for a term. Okay, and then you use the logarithm to dampen the difference between rare terms and common terms. Okay, so I think I hope this makes sense from kind of a heuristic point of view. Again, back to our original point. So the whole purpose of IDF, or inverse document frequency, to be able to capture this kind of intuition that those common words are not as useful as the rare terms or rare and more specific terms. And the inverse, the notion of inverse in the IDF is to capture this inverse relation. And as we can see in the three proposals, there are two additional steps just to be able to kind of resolve some of the issues that we had in the first two proposals. Okay, so this is kind of the heuristic approach to understanding IDF or inverse document frequency for term weighting. And again, IDF is so broadly used in text mining, in information retrieval, and in many other data science applications. And so I hope this helps you understand what this IDF is about and why, where did that come from. Okay, so this is going to be, again, the first brief video about IDF. So in future videos, I would like to talk about IDF from the point of view of probabilities, and then IDF from the point of view of information amount. Okay, so we'll see you in the next couple of videos. Bye for now.